Dear learners, I am Professor M.D. Agrawal. This is the second lecture of the third week, and topics of today's this lecture is Industry 4.0 Value Framework, RAMI 4.0 Engineering Core Framework of Industry 4.0, and McKinsey's Industry 4.0 Framework, and at end we want to discuss implementation roadmap for Industry 4.0. Last session we discussed very important areas like value drivers for Industry 4.0, then manufacturing processes, business processes. We discussed these kind of topics in the last lecture. Now these topics, we like to again revisit with the help of the example which I have shared in the first lecture of this week, this automation of the warehouse. And if we like to, in the automation of warehouse, basically, the automation is in all respects of, receiving the goods, selection of the goods, picking the goods, and then, dispatching as well as, sending to the right address, and then, refilling of the goods once, and, placing the order in case, in any item which is in demand in the market is in the, now it has gone down below the inventory level. So all these sort of things are the part of automation of, warehouse, If we consider the technologies, for this kind of automation, then, very important technology is autonomous guided vehicle, robots, then, 3D printing in case the spare part or, item, especially in case of the warehouses of the engineering companies, they also make use of the 3D printing for the spare parts which are not available and which require urgently. So this kind of, technology, if you see the map of the technology and, the drivers on the right hand side picture, it will be more clear. On the right hand side, you will find these are the drivers, value drivers, increased production, productivity, cost savings, faster decision, innovation. These are the value driver which a company will like to have that. Similarly, we have another value drivers are the partnership, how we grow in the partnerships, and value drivers like collaboration and how we automate the supply chain. So this is the value drivers. Then enabling technologies are like data-driven decisions. These are the enabling processes, data decisions, e-commerce synergy, automated warehouse, inventory automation. These are the enabling processes. And to enable these processes, we make use of the Industry 4.0 technologies like AI or machine learning or IoT, various technologies which we have studied, and some of the technologies we are going to study. So basically, if you have seen that, in the last lecture, we have seen how the value drivers, are important, how well the value drivers are important, for defining the roadmap of Industry 4.0 solution. Now, if I want to summarize that, first lecture in form of what we have learned, because we are going to use this learning in today's this session of designing the frameworks of the Industry 4.0. So first section we have learned the value drivers, like value drivers which I have already discussed in that example, like efficiency is one value driver, quality is another driver, cost reduction is the third driver, which is being enabled with the help of some certain technologies like AI, IoT, predictive maintenance, etc. Then value drivers like improving the customer experience, improving the customer loyalties, and personalization. This is being enabled. This kind of value drivers are being enabled with the help of softwares like product as a service, or CRM, or some other technologies are there, which you will be studying. There is a third category of the value drivers we like to see. We'd like to put partnership, collaboration, and innovation. So for that, also we have enabling technologies, enabling technology methods, and one of the important method is the APIs, which connect with the partner networks. So, and then another value driver is that decision precision, how well we are taking decision, whether our decisions are really going to work for the business, agility. So these kind of value drivers are being enabled with the help of data insights. So one side is the value driver, and then middle is the process. The process design in case of the solutioning. In case of solutioning, and that we will be studying further in how we use the processes in making the frameworks as well as. For example, we have the process like product design. This is one of the process. Research and development is another process. Simulation is the third process. These fall under the category of the design. Then we have the process like planning, demand forecasting, scheduling, and with the help of industry ERP, that is enterprise resource planning, also help us for that, getting the data, etc. Then we have the processes like supplier collaboration, procurement. These are the processes which are the part of that overall design of the Industry 4.0 solution for the manufacturing as well as other industries. So we have studied these processes in the first lecture. I thought we will try to have now a combined picture what we have studied. And the third thing which we studied at the last was the value chain. With the help of value drivers and connected processes, we are able to create a value chain. And the value chain is a very important aspect for the business, through which business run the whole show, like end-to-end digital linkages of supplier, manufacturing, distribution, and customer delivery and customers. This is a part of the value chain which we have studied. And there are many benefits of working like that in a value chain integration, data-driven collaboration, lower lead times, etc. So I thought we will have first a recap, and we like to see the value of this integrated map of value drivers, manufacturing processes, and value chain. And if you see at the end, all these three things together are able to deliver the operation excellence. Operation excellence is the one of the important aspect of any business, where you provide to your customer the best services, and other side you provide you make your business profitable, agile, so that any fluctuation in the market you are able to adjust that. Also it will ensure if we work in all these three value drivers and manufacturing process in integrated manner, it also have a value for sustainable growth, which we will be studying later on. So with this, let us move ahead for the study of two of the frameworks. This RAMI 4.0 framework, if you recollect, in my first lecture of this course, I introduced this framework. This was the fundamental framework, based on which Industry 4.0 was constituted, and it was being argued and it was being established that RAMI framework, and we are in a couple of minutes in this next 2-3 slides we are going to study this framework in detail. This framework is a layered framework. It has 7 layers: business layer, functional layer, information layer, communication layer, integration layer, and asset layer. So let us study these layers with the help of some examples. But it is being shown over here in the diagram also. These are layers. So when you want to implement or you want to work on Industry 4.0 framework of RAMI, we have to work in all these layers. Suppose we are doing solutioning of automated warehouse, then we have to work in all these layers, which we will see in a couple of minutes. In this slide, I am explaining that the meaning of each of these layers. So like business layer is a dashboard, present KPIs such as quality, productivity, matrices for strategic decision making. Functional layer may have predictive analytics optimized. These are all indicative elements or indicated part of the functional layer or other layers. But it worth connecting and understanding these layers with the help of some examples. So functional layer is a predictive analytics, optimize equipment use, making use of the equipment in optimal way. Then functional layer may be a quality control, functional layer may be a simulation. So all these aspects are to be the part of functional layer. And you will see that in case of functional layer, always technology is enabling all these kind of functions which are required in the business. And like for simulation, simulation is being enabled nowadays with the help of digital twin, which we will be studying subsequently in the next week. Digital twin. Information layer. All production sensor data is captured, stored, and made available for reporting and deep analysis. This is a part of the information layer. Communication layer is basically a network and communication layer. It is built, around the IoT, which we studied. And also for communication layer, we also need sometime the high-speed networks like 5G, 4G, and some other kind of networks. So communication layer deal with the communication between the different constituent of the solution and different branches of the company. And the integration layer, when you develop the solution, it may have the different parts. We have to integrate them. So integration layer deal with the integration of different constituents, different solutions, so that you can it provide a complete solution, Industry 4.0 solution. And then assets. Assets is basically the kind of assets you are going to work on. One is assets is your factory itself. Other is your machineries, robots or robotics. So these are the assets. Your software is one of the assets. So if you say that I have to develop a Industry 4.0 solution, this framework, REMI 4.0 framework, is one of the most critical, most important framework to understand. And you may have to see that your solution is addressing all these layers or not. So if you like to qualify this, with the help of some examples, so I'm again bringing the example of automation of the warehouse, which I have already explained you. And if you like to plot, all on the 7 layers, what all kind of manifestation of automation will happen for the automation of the warehouse. It is being written in the second column. Like in case of information, data models has to be formed. Data model has to be formed. And we have to also have, in case of information, we may have to also have optimization of the equipments. Like, we have to optimize the equipment. Similarly, in case of, functional warehouse control system has to be used over here. So this is an indicative list. This is not a complete list. And just for the sake of explaining this concept, I have put some of these, some of these processes that, automation methods. Then these are the enabling technologies, or Industry 4.0 technologies, and sometimes solutions also, which has been listed out over here. So if you like to implement, Industry 4.0 with the help of REMI 4.0 for this sort of scenario of automation warehouse, this kind of actions are required. One side, for every layer, you have to select, you have to understand and select what kind of automation, what kind of automation of processes to be done, and then for that, which kind of technology is more suitable. Next example, I am using the same that which we were using in earlier also, that in case we want to automate the quality and safety and productivity in a factory environment, we need to have this kind of technology drivers. Like in case of improvement of the quality, we have to have alignment of reality glasses to assist factory workers, machine vision to predict the quality control, very important. So if you like to plot here again REMI 4.0 on every action or processes of this scenario on the REMI 4.0 layers, this kind of scenario can be understood. Like for business, we have to define the goals, value chain. For functional, which kind of application services we want to run and algorithms. Information, what kind of data models we are going to use it. Information, again here, data exchange protocols. So I have prepared a indicative list of what is to be covered for each of these layer, and then to enable that, what kind of technologies are required, that is being listed out in second and third columns. So solutions and technologies and processes are listed out in second and third and fourth columns. So that is the implementation of REMI 4.0. So basically, REMI 4.0 provide you a set guidelines that if you want to implement in Industry 4.0 in any of the scenario of your business or in manufacturing or whatever, then you have to work in all these 7 layers, then only a complete solution can be arrived. Yeah, now I will discuss, there is another very important framework, which I call it business framework. And, McKinsey has, developed this framework quite a few years back. And, here, McKinsey discuss about the value drivers. Value drivers like, supply and demand match. These are the 8 number of value drivers, which McKinsey discuss that, if you like to make a framework, or you want to implement some, Industry 4.0 solution, you have to work for this kind of value drivers. So supply and demand match, time to market, quality improvement, resource and processes. We will see with examples all these value drivers. Asset utilization, maximize the use of machinery. Labor, increase productivity of technical work through automation. Inventory, reduce inventory holding cost via real-time inventory management, automatic replenishment. And service and after sales, enhance service and support operation using virtually guided self-service, digital performance management, and remote troubleshooting. These are all indicative, but these drivers, McKinsey has provided in its framework. This is the framework which McKinsey has released a few years back, and still they follow this framework. Though it's quite old, but still it's quite valuable. That's why I'm presenting this framework to all of you. You can see there is a layer of value driver, and these value drivers are being enabled with some kind of technologies and kind of softwares. So we'll see now the actual implementation. So a simplified view of what you are seeing in this framework, I have tried to make it in a table form. Like the value driver, supply and demand. You will see in that framework, data-driven demand prediction is one of the important lever. Data-driven demand production. And how it can be made enabled? This can be enabled with the help of AI, ML forecasting tools, digital analytics. Supply and demand is a very important value driver. Which are the levers? Industry 4.0 levers will make it is important for supply and demand mesh driver. One is the data-driven demand prediction, and then we have some tools, SOP and APS. Then we have to enable this, to basically actualize these kind of levers, technologies like artificial intelligence, machine learning, or digital analytics platforms. There are a couple of digital analytics platforms available. IoT sensors will be required. Time to market, rapid experimentation, simulation, concurrent engineering, customer co-creation. These are the methodologies which are recommended by McKinsey, and for time to market, because time to market means that as soon as the market requires the product, it should be made available to the market, the right product in the right time, and it should not delay. So for that, enabling technology, these are not part of the list of the McKinsey, but these I have indicated over here some of the technologies, like digital twin, simulation software, PLM, and all these things make possible this time to market. Digital quality management is the lever available. We will be studying that when we study global best practices. And advanced process, statistical process control. These are some of the softwares which are required, or these are the processes, I will say, not the software, which will be required to maintain or to guarantee the quality, machine. So you can see that for every value driver, McKinsey has provided a very good framework. If you see the quality in this quality, the quality can be ensured by digital quality management, advanced process control, statistical process. Inventory can be ensured by best size, real-time supply chain optimization, and also with the help of 3D printing, because sometimes the parts are not available. Then with the help of 3D printing option, you can make available that part. So McKinsey framework is also one of the important aspect in our study. And when you will be asked to develop a solution, you may refer this framework very well. So this slide gives us the key highlights. Two important things I want to mention. We call it digital compass instead of framework. It's a diagnostic framework designed to help manufacturing organizations to identify and prioritize optimization opportunities along the digital thread. And you will see that there is a convergence of business IT and manufacturing IT systems as part of this framework. These are two important things which we have to remember, that one side the business like marketing or customer demands or customer experience, other side the manufacturing processes like scheduling and operation. There are systems which cater to manufacturing processes like MES, and there are systems which cater the business aspects like CRM and SAP R3. They are being integrated also as a part of delivery process of McKinsey this framework. Now, if we again like to see the implementation of McKinsey framework, same example which I have referred earlier also, like this is a manufacturing process use cases automation to improve quality, safety, and productivity. This will be the indicative scenario when we like to see that, implementation of, McKinsey framework, Like, for quality, you will need the quality management software, and for that, we may have to have, some, processor, some technologies like machine vision and IoT sensors, etc. In case of, warehouse example, this kind of, value drivers, we can consider, like we want to improve the precision, we like to have the safety, we like to have scalability, and for that, we have the automation levers, which are listed in the second column. Like, we have the smart glasses, etc. These are the some smart glasses, which is very important. Like in case of robotic and autonomous guided vehicle, high speed shuttle systems, it will be providing that. So now the question comes that, how McKinsey framework relate to REMI 4.0? REMI 4.0, are they two different, buckets, or they have no relationship, So I try to introspect that, I try to relate them at the process level, at the utility level, and you will see in that, table, This is the table which I have, you can see in this table. One side that, the REMI 4.0 reference architecture, which we call a reference architecture of Industry 4.0, highlights are given. It has a focus on technical and architecture standards for Industry 4.0. Then it has, 3D module with 3 axes: hierarchy axis, life cycle axis, and layers, which we have seen in the 4.0 model. It has a 3D model, in the 3-dimensional model, and you can see the field devices one side, then the layers we have seen. So though we have studied only layers, we have not studied that, hierarchy of the levels, because it depends upon the kind of solution you are going to make. You have to use Industry 4.0 REMI framework. What is the goal? In case of McKinsey, it is very quite focused on business transformation and value realization and creation. And the framework, go in a very structured manner. For it is being guided by the value drivers, which we define the value drivers. What kind of value drivers we are looking for, like smart operation, productivity enhancement, quality improvement, cost efficiency, etc. Like, we want to enhance the customer experience, digital ecosystem, that is a partnership and innovation. So both, frameworks are having, their own space. One side, the REMI framework, is I call it sometimes the engineering framework, which is also required if we are doing any solutioning of Industry 4.0 scenario. And McKinsey framework is also require understanding, and implementation also require for any Industry 4.0, because what kind of value it will create, what kind of advantage it will give the customers and the business. So we have to have some sort of the bridging between these two frameworks. That's why I thought we'll present both framework, rather than studying only one or second framework. And in the below, I have given that again some of the key difference or key highlight, like origin of the REMI framework was in the Germany, and while the McKinsey is from the McKinsey, focus is interoperability architecture and standardization, here value creation. Outcome is a reference architecture, and this is a transformative roadmap for digital adoption. So now, considering all these facts, all this discussion, all this kind of concepts, I like to now I want to make a roadmap for implementation of Industry 4.0 solution. And this sort of study which we have done in last this lecture and the previous lecture, the culmination of this study can be further understood with the help of a combined picture. This combined picture or combined slide, where in one block I have discussed here the digitalized manufacturing value chain, which we have discussed few minutes back. Then what is the REMI 4.0 architecture we have discussed a few minutes back, and McKinsey 4.0 value compass. So I mean that when you want to make a Industry 4.0 solutioning, you have to understand that these three pockets, if you like to go in a very structured manner, and and you may have to understand, and you have to make you may have to create a solutions around the value chain. Then you have to implement, you have to select that what kind of your solution is addressing the requirement of different layers of REMI 4.0, and then what kind of value drivers you are using as per the McKinsey framework. So these three things, three important dimensions of any Industry 4.0 solutions is very important to understand for implementation. This is a simple implementation plan step by step I have created for just sake of this study. That one side, once we define the problem statement, like problem statement by the automation of the warehouse or automation of the quality and productivity, then that is the problem statement. Then we have to have, after the problem statement has been defined, then we should find out the business processes which we want to automate, which we want to enable, which we want to improve. What are the business processes which we want to improve? Like process. For that, we require tools like process map, value streaming. And which value driver we want to work. We have discussed enough about these value drivers. Then we should have the industry to enable these value drivers, what kind of levers we require. Like the levers, the industry levers are like softwares and technologies like analytics, digital twin, robotics. Then what kind of integration we are looking for and how we will measure this progress. What kind of matrices we would like to define that using some analytic tools and dashboard. And finally, we draw a implementation plan in terms of phase rollouts, pilots, training, leadership, and buy-in, etc. Project plan, change management, training program. These are part of this exercise. So this is what I thought I'll present in today's this session. Reflecting back that there are a lot of studies which are available in this domain, and one of the studies I am reflecting back over here, and this study has summarized that the key technology players like Wipro and TCS, Capgemini and SCL Technology, Accenture, etc. What kind of framework internally they are internally they are working. So this is again a ready reckoner for anybody who is working in the technology space. But I will say that still we have to see a wholesome approach which we discussed a few minutes back, a few seconds back. But this is also a good guidelines for anybody who want to understand quickly that how technology players are using the concept of Industry 4.0 framework, and when they want to give the solution to their customers, what is the solution, their focus. So, like in case of solution focus for Wipro, what the document this says, research says, you can study the research, digital and physical automation, IT/OT integration. In case of TCS, the solution focus is a smart manufacturing IoT integration. In case of Cognizant, smart manufacturing. So I also thought, let me have a what is happening in the industry. Let us also present that map to you. So with this, we come to the end of this today's session, and where we discuss, value framework, then we discuss RAMI framework, and then we discuss McKinsey Industry 4.0 Compass, which is also considered as one of the framework. And then we have seen how this can be, the learning of these frameworks can be used for developing a implementation plan for Industry 4.0 solution. Thank you very much.